Hello student, the question says two concentric conducting thin spherical shells A and B having radii RA and RB, and he has given RB is greater than RA, are charged to QA and minus QB, and he has given magnitude of QB is greater than QA. The electric potential along the line passing through the center is. So X measures the distance from the center. So let us draw this scenario. We have two shells RA and RB. Remember, number of shells are two. Let us first, before solving this, you should know what is the potential due to a shell. So potential inside a shell, inside a shell is basically a constant. That means inside a shell, the potential is constant. Right now, I will not tell you why it is constant and all that. Just remember that potential inside a shell is constant, and its formula is K into charge of the shell divided by radius of the shell. Whatever is the charge of the shell and divided by radius of the shell. Next, potential outside the shell, outside a shell, that means outside means outside the surface of a shell. So what is inside and outside? Let me just quickly explain. Any point here, here, any point, this is basically inside. Any point here, this is basically outside. Okay, so these are the two important points. Next, potential outside the shell is not constant. It is K Q by X. What is this X? Let us say I want potential here. It is the distance from the center of the shell. Remember, X is the distance measured from the distance from center of shell. Now, once we understood this, how do you find potential at a location? If you want potential at a location, potential at any location, at a location, is simply sum of all the potentials, because potential is a scalar quantity. If we don't have one shell, if you have multi-shell, these are basically multi-shell, one shell, two shell. If you want potential at a location, simply potential due to first shell, potential due to other shell, and so on. If you have n shells, this keep on going V3, V4. If you have more shells, Vn. So this is how you will find potential at any location inside a shell. But you have to be careful. Particular location could be inside one shell and it could be outside in another shell. Now let us try to solve this problem once we understood this. First, he is saying X is the distance measured from the center of the shell. So let us travel some distance inside the shell. Let us consider some point here. Some point. Okay, let me call this point P. Okay. So if I consider point P, what is this point P? Point P is a location X lesser than RA. X is the distance from the center of these shells. For both the shells, the center is same. So X is lesser than RA. Whatever is this distance that you have taken, it is lesser than the radius of the first shell. Now we can say if you want potential at point P, it is simply potential. There are two shells involved. Potential due to shell 1 plus potential due to shell 2. This point P is inside the shell 1. So before solving it, write down, okay, in the shell 1, it is inside. This point P is also inside the shell 2. So this point P is also inside the shell 2. Now what's the formula for inside? It is KQ by R. So K QA divided by RA. Since here also inside, the formula is KQ by R, K QB divided by RB. But since it is negative, I have to write minus K QB by RB. So if I get K common, you will get QA by RA minus QB by RB. One thing is sure, this is constant. So till X lesser than RA, because QA is constant, RA is the radius, which is also constant. QB is constant, RB is constant. If you notice it, there is no X term only in this expression. There is no variable term only. Since there is no variable term, at X lesser than RA, it has to be constant. At X lesser than RA, he has given there is nothing here. There is no constant word, nothing is given. So this is wrong. And there is, and one more is that here also at x lesser than RA, no constant is given. Okay, because it is continuously decreasing. Here there is nothing. If you notice it, x lesser than RA, we got a straight line. Here also x lesser than RA, we got straight line. So answer could be one of them. Now let us continue to the next stage for the same problem. Let us consider a point somewhere here, some point Q somewhere here. Okay, Q might be look like a charge. I will take some point S. Okay, so let me call this distance as X. Now this will become my distance X. So again, potential at point S. Here, this point S, interestingly, it is greater than RA. This point is greater than RA. If you measure the length X, it is greater than RA, but lesser than RB. So similarly, potential at S is potential due to shell 1, because we have two shells involved, right? Potential due to shell 2. If you observe it for shell 1, this is outside. This point S is outside the shell 1. This is my shell. If you notice it, this is my shell. This outer layer is basically a shell. So this is my shell, and my point is outside the shell. So we can simply write for the shell 1, this is outside point, and for the shell 2, this is the shell 2. For the shell, this point S is inside. So I have to use inside outside formula. So for outside formula is KQ by X. So K QA divided by X. X is the distance from the center. Suddenly a variable came into picture. For inside, it is KQ by R. So K Q divided by R. That is RB. If you notice it, suddenly we got a hyperbolic function. Potential it's shell, you got KQA by X. We got a variable in the denominator. Here, this entire thing is a constant. I'll call it as minus constant. If you observe this carefully, the potential is slowly decreasing with the distance X. So if any y function decreases with the distance X, that is like similar to a hyperbolic function. In a hyperbolic function, you get a graph in this way. You get a graph in this way. So by the time it reaches outside, we got a hyperbolic function. So straight away, there must be a hyperbola after that. From these two options, the only option between RA and RB that is showing hyperbola is C. So we can directly mark the answer is C. But before concluding, let us look at the other part also. But right now, we no need to solve it further. We will mark it. We'll mark this as our answer and we'll go for the next problem. But let us continue and see whether how we will get the entire graph or not. Let us look at the last part. So in the last part, if I select any point, some point Z or something like that, some point Z, because initially I thought PQRS, but Q is taken for charge, R is taken for radius, unnecessarily confusion will arise. So I'm taking some random names. Okay. So I want potential at this point Z. So I want potential at Z. If you want potential at Z, this is X is greater than both RA and it is greater than RB also. It is greater than both of them. So indirectly we can say X greater than RB. So at this location, if I want potential, let me call this distance as X. So potential at Z is equals to potential due to shell 1 plus potential at any location. If you want potential, you have to do potential due to all the shells. For this shell also, this point is outside. For this shell also, this point is outside. Since it is outside for both of them, the potential at this location would be K QA divided by X. X is a variable, understood? So you can substitute any value, plus K into minus QB divided by X. So we basically get K by X into QA minus QB. the author has clearly given that QB is greater than QA. Magnitude of QB is greater than QA. That means this whole value would be negative. Suddenly, our graph must be negative and it must follow a negative hyperbola. Negative hyperbola means suddenly from positive axis, it will shift to the negative axis. So it will shift to the negative axis. And here it has to follow a rectangular hyperbola. You can clearly see that beyond RB, we are following a rectangular hyperbola. So here, that is the reason why we have selected option C. This is how we are supposed to solve the problem. But let us see, is this the only way to solve this, or do we have any trick to solve the problem even more easier? Let us see how to solve this problem qualitatively. Like you have to feel it and you have to solve the problem. First, if I select this point P, it is inside both of them. So inside both A and B, so it is inside both the shells 1 and 2, both 1 comma 2. So we get a constant value. Since we need to get a constant value, since it is inside both of them, we need to get a constant value. So we can eliminate option 1 and 4. Okay. Now we have option 2 and 3 left. Now imagine a positive charge here. Imagine a positive charge struck here. What will this QA would do? QA would try to repel this positive charge. What will this minus QB would do? Minus QB would try to attract this positive charge. So this QA will try to repel this positive charge because positive gets repelled. So if I try to draw the electric field lines, the electric field lines would be in this direction. And because the field line would flow from positive charge to negative charge. So this will be the direction of field lines that would be coming in this way. And remember, in the direction of field lines, the potential has to decrease because field lines flow from high potential to low potential. This should be high. This potential must be low. So between X lesser than RA and RB, we can directly qualitatively say that potential has to decrease. No maths equation, nothing is required. Potential should decrease. Since potential should decrease, the only option that is showing potential to decrease is my option C. If you notice it here, only the potential is decreasing. In option B, the potential is still constant, whereas in option C, the potential is decreasing. So based on qualitatively also, we can say that the correct answer for this would be option C. So we have eliminated option A and B. Potential should decrease. So that means the correct answer would be option C. This is how we mark the answer as option C. And remember, the key concept is what is the formula for potential inside the shell? What's the formula for potential outside the shell? How do you find potential at any location if you have multi-shell? Simply shell 1 plus shell 2. Write this step by step. Don't rush these problems. Once you mastered it, then you can rush solving these problems. Hope you understood how I have solved. Thank you.